Hey everybody, good to see you again. It's been a little while since we've had our regular meeting, or full meeting. But today we're going to be giving some updates on feeds validation for Polkadot and Kusama and parachains. And without further ado, Vad, if you want to take it away.
Yeah. Hey everyone. Let me share my screen. All right. Cool. Okay. Specifically, what we worked in the last week on the feeds was
Hey Vad,
before.
can you zoom in a little bit, please?
Yeah. Okay. Cool. Does it work? Does it look okay? Yeah.
Looks great,
Cool.
thank you.
Yeah. So the first PR that went in was extracting object mappings only for the successful X6. What we used to do with the feeds before was we used to pull out all the objects into the indexing, whether irrespective of whether the X6 was successful or not. With this change, what we're going to do is that we ensure that we only map those objects that have been successfully validated by the runtime. Uh, so how we do that is we kind of look a block ahead and get all the successful validated calls, and right before we extract object mappings, we pass in those calls to as if they are the expected output. And but the state doesn't exist at that point because we are still taking the previous block itself before when we are extracting the object mappings so that it looks on the checkpoint validation, everything goes as is. We're just passing an extra call by looking in a block ahead and then getting those validated calls here and passing them in. So with this, essentially, runtime would have access to a list of extensives in a particular order, in the same order. The extensives were added as part of the block. And what we do here is we only extract those. Let me find that particular. Yeah. So we only extract the object mappings only if that particular extrinsic is already part of the successfully validated calls. If it's not validated, we just ignore it. Only if it's validated, we take it in. Now, with this PR, what we added was a new API called Objects API. Let me quickly find that. Yeah, there you go. Cool. The Objects API has two functions, basically getting the validated object calls, and this one is the function that we have it as part of the Subspace API earlier, and that's what actually caused all the API runtime API uh, breaks here was that we ended up moving this particular function from Subspace API to Object API because it makes a lot of sense to actually have them logically grouped here because these are the same exact functionalities. So that was on this PR. This one was landed a few days back, and uh, post that, we have a few more things happening that came out of this particular PR was we broke it. We essentially broke the current nodes because we introduced a new API and we removed an existing API without any migration properly. So that leads to a new PR that actually went in yesterday. What it basically does is fill in that particular block that we have removed from that particular function we have removed from. So we just added this back so that the old nodes are still happy, or the new nodes are still happy with the old runtime, vice versa. And we kept the existing logic as is. It's just that the new nodes will explicitly call, if you look at this one, the new nodes will explicitly call the objects API right now, irrespective of whether which runtime it is, so that it's easier, so that we can migrate without any forks in the next one, so that the nodes get automatically uh, upgraded without having to do any forks like this. That this was mainly patching that particular API. Post this, we have one more that I was talking about, importing blocks in the reverse order. So we had this particular issue that we've been tracking, feature validation upgrades. There were two stages. The first one, actually, let me check this one out here. The first one was validating from block zero till the current tip, but the validation starts at some point in the future. There is no backward filling. The second stage was supposed to be the backward filling. So we have the validation point and we fill backwards and forward. Forward always happens with validation. Backwards just fills up because we already assume that the descendant of that particular parent is already validated. So this was a pretty straightforward change. In like there was a bit of back and forth between me and Nazar, because I think we both were on a different pages in terms of whether to keep both the stages there or just remove the first stage and just only keep the second stage of functionality into the feeds. What we ended up deciding was to remove the first stage. So that means that at this point, if you want to start importing feeds, you have to give a validation point. That validation point could be the genesis. In that sense, the chain will only move forward. Or if you give the validation at some point in the future, the chain can move forward with the live tips, and the relayer can also push in a reverse order till the genesis if the genesis blocks are missing between that point. So this was this particular PR was mainly basically the change and removing unnecessary things that we didn't have to maintain. Uh, the crest of it is here. Basically, if the we what we do is here we manage two states, the the latest step and the oldest parent. So that we move in the same direction sequentially in the reverse or in the forward. So in this one, we always check if the block is the oldest parent that we have known. Then we take that block and then we update our known oldest parent to the target block's parent, so that because that is the oldest parent so far, and so on and so forth, we go up until block zero, and the remaining is pretty much going forward direction here. Is if the validation block uh, if the target block is above or equals to validation block, so we validate it and then we import the block as is. Um, that is pretty much it about this one. And there was a small cleanup that came in. Nothing major. We just had to. We just had to remove some cleanup code there that came in before the reverse order importing happens. That is all on the code side of things. Uh, on the parachain validation, uh, I'm guessing like Jeremiah and Bizarre like, do have a look at it. I would ideally like to discuss if you guys have any questions on that or if you're clear on that particular spec. Ideally, that would be the next step for
Can
us
you share
on
your
the feed side.
can you share your screen and just give us like a 5-minute overview of what you have
Yeah,
in this, what you're thinking?
yeah, yeah. Okay. Um, so basically, okay, can anyone see the screen?
Yep.
Okay, cool.
Yes.
Basically, parachain validation is quite different from the relay chain. And like relay chain, we have a set of authorities that we keep track of in a given set, and then we ensure that the new blocks are always signed with by those authorities itself, and those blocks always contains the authority set changes in the next set. So we update our state accordingly. With parachain, what it basically is that the parachain itself follows the relay chain, and relay chain, and it doesn't have its own finality aspect of it. it derives it from the relay chain. So how relay chain, how parachain derives that finality is basically in two steps or in two blocks ideally, but not always. Depends on how the validators are working. So first, the parachain block is backed by a small subset of relayers or the relay chain validator nodes. That once the block is once that particular block is backed, there will be another event where all the authorities sign off on that block being back in their own state. That is the block inclusion, and that happens when the quorum is reached. So that's why I said ideally it's two blocks, but it depends on how depends on the network itself. So once the quorum is reached for the signatures from authorities for a given block for a given parachain is back, then it moves into inclusion state. The inclusion state is pretty much what parachains call it a finality. So we cannot, but if we want to do something similar on relay chain or on a runtime, we cannot do that because it's a lot of state and a lot of process that relay chain keeps track of. So what we ended up doing was essentially kind of like proving storages on relay chain that a particular parachain head is already included in the relay chain head in the relay chain state at some point in time. It doesn't matter which one it is. Uh, so what we essentially found was that there is this one particular storage under. I've given the links there. There is this one particular storage called parachain heads. That's just a map item that maps to a given parachain ID to the vector of bytes. The vector of bytes are basically the encoded bytes of a encoded header information of a given parachain that is backed or that is included. That is the latest included header of a parachain map. What we ideally need to prove is that for a given parachain, if you want to prove that a parachain,
Hey,
the
sorry, Ben.
parachain,
Can you hear me? Your audio cut
yeah,
out there for a second. I just wanted to make sure I understood what you're saying. So
okay, yeah.
in
So,
let me just rephrase, make sure I understand. In every relay chain block, there is a map of for each parachain, what is the latest included head? Like what's the
yeah,
hash block header?
yeah, yeah. For every, I mean, not in every block, I would say. Uh, Relay chain state itself contains a like a particular palette. I think it's Paris. I think that's the name of the palette that contains paraheads. Is a state. It's basically a map of a parachain ID to its latest known parachain head. So the head could be some block number.
Okay.
That
But is that something which is recorded in the relay chain block, or do we have to like query a full node over the RPC to get that information?
Yeah. So it is not recorded in the block. What it is? It is recorded in the block, but the way that they moves it, it's difficult for us to map which header belongs to which parachain ID from the block itself because they use something called cores, and core could be randomly assigned to a given set of validators, and those validators are randomly assigned, and that core is assigned to a random para ID in a given session, and the para ID could be recycled. That code could be recycled and used to a different para ID. So that's what I mean by tracking a lot of state. So instead of doing all that, uh, what it does at the end of finalizing a particular parachain block is they update the state of this particular head, the map that, okay, this parachain ID, this is the latest finalized head, right? So, and once we have that, the chain and then the block gets like I mean it's part of the state once a particular extrinsic gets executed. This is a valid unsigned extrinsic that happens in every block. So once that extrinsic is done, the state is updated. Now ideally how we can prove that is at that point in the block after the block execution, we just need to fetch the storage proof of that particular storage value, and the storage proof would ideally leads to the storage root that is part of the relay chain block head. Does it make sense?
It makes sense, but it feels like there's a simpler way to do this. Um, the way I understand that it works with the relay chain is that there's a backing, then there's an inclusion, and then that inclusion, once it's finalized by grandpa, so after 3 blocks of being included, it's considered like finalized, like it's never going to change from the point of view of the relay chain.
Yeah, like in the partial validation, grandpa has nothing to do with any of this. It's just that once a particular once a quorum has reached that all a bunch of valid authorities back that particular head of a parachain, it is moved to the inclusion state, at which point the relay chain finalizes it by putting that head against the para ID into the state. Now,
Well, I don't think finalizes is the right word. It just confirms it. It's
like
not grandpa
that.
final.
I think,
But even if it's confirmed in the relay chain, that doesn't necessarily mean that that can't be forked out, honestly. Like there can't be a reorg. So that's why you have to wait for the grandpa finality gadget to kick in before it's considered locked
Right,
in.
but you are only archiving finalized
but-
blocks.
yeah, but we're only archiving finalized blocks, so that
Sure.
means that it's already finalized. So this is already
Well,
inferred.
I'm trying to be clear in our description here. I understand that we're only doing final
Sorry.
block, but it's not like it's just when it's included in the block from the point of view of the relay chain. It's when it's the finalized block in the relay chain.
Yeah, like on the parachain validation side of things, when the particular implementation of trade that we rely on to actually verify this proof, we just need, this parachain validation basic expectation is that, okay, for a given proof, the storage proof, I just need you to tell me whether the proof matches the storage root at a particular block. And since it's completely on the grandpa side of things, whether how on the relayer side, how we are pushing the blocks, whether when we are pushing the blocks after the finalization, or so that's why I didn't include that particular implementation detail here.
Sure. When you say storage proof, you mean storage proof to the state, not to,
Yeah.
Okay. But I mean, the para block header has to get included in the relay chain for, I mean, that literally inclusion means that it's in the block, right? It's like, it shows up as like an extrinsic in the block. Right.
I guess, but maybe you can explain to the end, like what is the solution, that it will become clearer why that is actually simpler than tracking transactions.
Okay. Cool. Give me a minute. I wasn't prepared for this, but
I can try to give like 30 seconds explanation.
Okay, go for it. Go for it. I just want to show that to you in Subscan, so that it's easier to look at extrinsics and derive what exactly we look at. But give me a second.
So
Naza, go for it.
The idea is to submit parachain block and a storage proof that it is actually part of the relay chain. What it gives us is ability to not look into transactions at all. We do not decode them at all on the runtime level. They're just like bytes. We don't have any notion of the parachain in the relay chain validator. It just validates grandpa and nothing else. And state root is something that is very common for all the substrate chains, regardless of consensus. And in the relay chain, all we will do, we will just create MMR of those state roots. And on the other side, relayer will use off-chain storage on the blockchain, on Subspace, to track that MMR and being able to generate proofs. So when new parachain block comes in, we generate MMR proof that it is part of the relay chain. And then on the blockchain side, we will reach out to the feed of the relay chain, make sure that the proof validates. If it validates successfully, then we can include parablock. And that allows us to, in the future, have other kinds of feeds. Basically, anything that can be put into storage can be proven with this mechanism. We do not need to hard code the notion that this is the transaction that corresponds to the parachain. It looks like this. It has this structure. Like all of that is basically opaque as far as relay chain feed processor is concerned. It's just like universal proofs.
But there's more overhead for that.
There is less overhead, less processing. You don't need to
there's more storage overhead, larger transactions, because these MMR proofs, because we're proving data that's already in there. We're just trying not to process it in the runtime.
It's not there. Like we are not storing it in the runtime.
Well, I guess what I'm trying to say is we already have the block which has the para block headers in it.
Right, but it's not straightforward.
It's not in the state.
But it is not straightforward to actually know when that
Right.
particular
No,
para
I
header
understand.
has been
I understand.
included.
I'm just trying to I'm just
Okay.
trying to say the trade-off is that instead of interpreting the block and mapping them in the runtime, we're just doing that. We're providing some additional bandwidth and some additional storage in the transaction of this MMR proof, and then we have to validate this MMR proof instead back to the relay
Yeah.
chain header.
Yeah, and I think it's actually a positive trade-off because we are basically trading the size of that transaction for the reduction of the state in the runtime. And state is
And,
more scarce than the history, so.
and
What
also
additional
potential
state do we
processing
have?
power. So sorry, go ahead, German.
What additional state do we have? Because I mean, we just have a map of relay chain, like parachain feeds and what their last finalized
No,
head, right?
with this, we have to keep track of who signed what for every block, for every para head, for every para chain. So we have to essentially replicate the quorum that relay chain does, because the signatures of authorities for a given head could be not in the same block, but in any other blocks further. So we have to maintain the entire quorum, or the at least the signature count of that particular para head of a given para chain, and then move it manually. And if we do this, we will essentially cannot be able to prove the para heads like we prove the relay heads as well. Like with relay chain blocks, we can prove with just justification and a current set of authorities. We cannot do something similar with the approach of tracking the para heads till the quorum is reached, and then updating our runtime state, and then cleaning up or purging up all the state. That's a lot of state to keep track of, a lot of things to store in between. And that's one reason why, since we already have a storage route that's coming as part of the relay chain block header, we could just add them into an MMR pool as and when a new block comes in. And then the MMR pool is ideally maintained as an off-chain indexing thing, and relayer could ideally generate a proof for that MMR from the MMR pool that this particular storage route has been included, and we provide another proof to that storage route saying that this particular head proves to this particular storage route. And when that happens, then it is essentially proven at least on the parachain side, keeping things much more simpler on the grandpa side and parachain side. It's just that, okay, given a set of proofs, verify the state root, and then check the MMR state root inclusion. If that happens, then this is the latest para head, and then we move to the next one. And if that particular proof comes as part of the block itself as parachain block, so anyone outside DSN could potentially re-replicate the MMR pool and then can potentially prove the parachain head inclusion as well.
Yeah, and in the runtime, we only need to store like the peaks of the MMR, not like all of the leaves. We can store leaves in the off-chain storage. So it will be still like stateless, like the relayer will be stateless. It can query everything from the node, but it will not be part of the runtime. So it like basically very little state that needs to be stored.
And who maintains the MMR proofs and generates them?
So the off-chain indexing on the node itself. So that is the core, another piece of discussion that we would have to decide on. Like who will ideally do that? Like so, or at least the node can do it, because that would be the easiest way of doing things, because we have all the proof generation.
Are we talking about?
Sorry, our subspace. How do I put it? The execution node, or executor.
Just subspace node.
Just subspace node. The subspace node that we're running.
We're talking about an executor here.
Yeah.
Well, I guess in this case it's a farmer because it's still in the primary.
It's still in the farm. It's in the farmer runtime. But yeah, whichever holds this particular runtime,
So
that particular node.
The farmer has to maintain an index of the MMR proofs or the MMR heads for all of the parachains?
No, just for relay chain.
Just for the relay chain. So that will be, if you include Kusama, that's one MMR pool. If we can be even more efficient with that. We have one single pool for all of it. Again, like it depends on how much indirection of proof verification that we want to do. Here we have one indirection.
Okay. Sorry, Beth, I just got a couple questions. I'm just trying to understand this. So the MMR root is tracked in the state, or is that in the block header?
The MMR is tracked in the state, but anyone can generate that MMR by just looking at the blocks.
Well, the MMR is the proof. Just to be clear on terminology here. So there's a root, and then there's these storage proofs back to the MMR. So the root is tracked in the state of the relay chain?
Not the root, all of the peaks.
There is no root in MMR because the peaks are the ones that we
I
store.
mean, yes.
I mean, there is root, but it's like, okay. So you cannot just store the root and append a new element with just the root. We need to have all the sets of peaks and nodes to actually do an append, because the root changes on every append.
Sure.
And you don't need to have all the nodes, you just need to have the peaks up until that point to actually do an append. So what we do is that instead of storing the root hash, we just store the peak hashes, and the off-chain indexing stores the leaf hashes as well. So the peak hashes ideally are very minimal in that sense, like they grow very slowly. If you look at the actual MMR implementation, it would be much more cleaner, like how many peaks could be over a period of time. I do not have that number on back of my head, but
So
it's not as big as.
peaks?
Sorry?
Are we just doing like the last 32 peaks or the last 256? Or are we just doing like all the peaks?
Oh, all of them.
All of them. But once you start pruning, it would just be peaks. Like you don't hold a lot of data at all. It could be like if you think about it, if you have
the number of items in the Merkle Mountain range?
It's not linear. Like if you build like one kind of like tree, and then you create a smaller tree after that, and smaller tree after that, and then like combine together in the bigger tree, and you create smaller ones again. But all of those like leaves from the big tree, we don't need them. We need just a peak from that like big mountain.
Okay.
So we will store those peaks so we can like proceed with appending this Merkle mountain range. But off-chain indexing will store all of the leaves so you can generate proof later. Like Relayer can generate a proof that this parachain is part of this state.
Okay.
Because you need leaves to actually generate proofs.
So we're not querying the proofs from some RPC node or some full node. We're basically like storing all this on the Relayer.
We do store it on the node, but in off-chain context.
Okay.
And instead of having database connected to Relayer can just query that off-chain context directly.
Okay.
It's like a database basically, but we don't have database.
It's just only database that is very local. Like you shouldn't use that for consensus. Just to ensure that this eases up things for us in maintaining MMR, proof verification, proof generation, and all much simpler, because most of the work has already been done on top of it. We just be taking pieces out of things that we want to get this up and running faster. Gets us there much faster. That's the whole reason why we are like seeing off-chain would be a better idea to go with.
Okay.
Let me continue. So
I think Skylar's gonna have to leave in a little bit for office hours. I think I can go through the rest of this on my own. It makes sense now. Unless you have any specific questions, or Nazar, you have any other feedback, we can probably move on. Nope. Okay.
One question for me is that we have, as part of the leaf node, at the moment we just have only state root. I've also included the extrinsic root as well. I'm not sure, Nazar, if you think we would use extrinsic root at some point to actually be included, but I felt like that was a good idea considering the fact that this would be only one MMR pool per relay chain that we could create in an efficient manner from the get-go. So I want to see if we can get most of the things into it for the inclusion.
We can. If you can come up with a few use cases where we would want a proof to the extrinsic.
I don't know. I haven't thought about it, but there is a use case somewhere that we would need.
It will make it.
Okay. Okay.
Because at that point we can't go back, because so that's why I've included there. But anyway, if you guys think something otherwise or opinion about it, let me know. If not, then we can keep it as is. Yeah, that's it from my end. If you have any questions, let me know. Happy to answer.
No questions. Thank you, Ved.
Sorry, I took most of the time off.
That's okay. That's what we're here for, is to answer these questions. Okay, let's do this. Skylar, if you want to go next, and then we'll let Serge go, just so that you can give your update in case you have to drop off, Skylar.
Yeah, sure. Thanks. Hey, everyone. So just updates on the parachain auctions for Polkadot and Kusama. Last week, Polkadex won the 16th auction for Polkadot. They bonded 9.4 million USD. So that was a new low for them, for Polkadot. This week, we should have another one in about 6 hours. Origins Trail is leading that one with a new low of 7.5 million USD that they have bonded. So that's probably where we're looking for there. So 2 new parachains on the Polkadot side. On the Kusama side, Shiden won last week to renew their slot. They were the fourth or fifth parachain to win in Kusama when they first started. So they originally paid 10.5 million for the bond. Now they're going to be able to renew the slot for under 1 million. So about a 90% price reduction there. So yeah, it's Kusama took a week off between slot auctions, so it's a little bit slower there. But interesting thing about Shiden, they actually were doing a new crowd loan for this auction. So they are still raising funds and giving out rewards to the community. And they shared some metrics, which I thought might be interesting. They aimed to raise 1.1 million. They raised a little bit less than that, but they offered 0.5% of their token supply for this crowd loan. So 0.5% for a 1-year slot, which ended up, the 0.5 supply compared to their market cap ended up being about $150,000 that they, are giving out in rewards to raise 1 million. So thought that was pretty interesting. They actually have 30% of their whole token supply allocated to crowd loan rewards. So they're probably going to keep doing 0.5% for the next, I don't know, however long. That would last for 60 years if they continued on that pace. I was just surprised to see 30% of the token supply allocated for crowd loans. So that's pretty interesting. That was the last one to win. So that brings us up to date on the parachains. Right now we have a few in the backlog to add on to the relayer. We've talked about this before. There's 3 Polkadot chains, 3 Kusama chains, and then 3 of the Kusama chains that are swapping to a new slot. So those shouldn't be a problem. But it sounds like On Finality is having a trouble getting those feeds. Serge messaged Gary last week, and Gary said they have one of them currently on the marketplace, and they're talking to the others. But he said it's about timing and where they're at in the roadmap for when they can make those available. But that was 7 days ago. He said he's going to follow up with them to see what the progress is there. So I don't know if you have any other comments on that, Serge, but that's where we're at with parachains and the backlog.
Yeah, I have a comment. So there is endpoint for Mangata on Kusama, and I tried to add them, but currently on finality endpoints with our API key, they do not work. And I messaged them, they created a ticket, and I don't know if everyone received email or just me. So yeah, I need to wait until they fix it. And yeah, that's it.
Cool. Thanks. Does anybody have any questions about the parachain process, the auctions, or anything? I can provide more information next time. If not, thank you.
Thanks, Scott. Serge, do you have any other updates on your end regarding any work you've been doing on relayers or parachain integration?
On Relayer, mostly I was doing a deployment no like code updates, no new features, but yeah, I will have to update to integrate those changes, recent changes on the runtime shortly.
Okay, great. Any other open items we need to discuss before we close out? Okay, well, thank you very much for watching, everybody. We will see y'all again next week.